Nowadays, almost any printer can make good looking prints. But prints like these hide all the inconsistencies, and unless we test the proper way, we'll never know the true print quality performance of these machines. So to properly benchmark that, I created a series of test prints that expose and will show the true capabilities of these printers. So do Creality K1 and K1 Max live up to the print quality standards of Bambu Labs X1C? Well, you must see every test to actually get grasp of what the real difference is. I have been testing and modding printers with the help of a long time, and today's video sponsor PCBWay. If you require not only PCBs but also professionally made parts using CNC machining or even 3D printing from metal for your projects, check them out and get discount for your first purchase, especially as ordering process was never this easy. A very important note before we dive into the testing results is that both of the printers were updated versions both hardware and firmware wise, and they didn't have any mechanical problems as they were shipped in an insanely secure plywood case by Creality. I like to start with determining the actual max flow of the printers, as companies really like to overstate their numbers. And there was no surprise with K1 and K1 Max printers. Both fell short and capped at around 20 cubic millimeters per second of constant extrusion. Measuring the X1C hot end performance is impossible on the printer itself, as it prevents over extruding, but I have tested the hot end on another printer in the past and it started struggling after those same 20 cubic millimeters per second, so neither printer comes even close to those marketing claims. So great, they can both melt the plastic, but can they also sufficiently cool it down? To test that, I'm using my model, which is designed in a way that if it doesn't have any defects, the cooling is fully sufficient to print PLA with high overhangs. The smaller K1 with only printhead fan active performed great on the left and the back sides of the print. But it struggled with the front and just tiny bit with the right side. This means that a fan deck doesn't have an optimal design to cool all sides equally. However, the print looks perfect if we additionally turn on the auxiliary fan. You might think that the cooling performance of a bigger K1 Max would be equal, as both printers have identical printheads. But because there's so much more hot air around from the heatbed, it performs worse in both same directions. But again, it all changes with an auxiliary fan on, making a perfect print. In comparison to the Bambu Labs X1C, both K1 and K1 Max fall short when only using the fan on a printhead. And with auxiliary fan turned on, all these prints look flawless. But what's impressive here is that X1C is beating both K1 series printers while making lower noise levels. But what about when printing enclosed? At this aspect, K1 Max feels the quietest overall, while X1C with a recent update that implemented motor noise cancelling makes a huge difference on straight lines. When traveling and doing fast movements, it is the loudest printer in this comparison. The smaller K1 is a strange one, as when printing, depending on the speed, it makes all the frame resonate, and sometimes it can be way more audible than even the fans. But if I had to list them, the least annoying when printing PLA is X1C, and when printing ABS, the K1 Max. Next we have the extrusion consistency test. This mostly shows, well, how consistently the extruder and hot end can print. Keep in mind that this is a print in a vase mode, which makes it thin and flimsy, and the further you go from a build plate, the results will get automatically bad. So the true star is stalled by the lower layers. Here is where I ran into a consistently inconsistent extrusion with both K1 and K1 Max. While X1C results weren't perfect compared to even my budget Warren 2.4, they were significantly better than K1 series printers could produce. Traveling into the future, after I ran all the tests, I wanted to solve those ugly layers. The first thing that I tried was using boron nitride paste on the heater, because the hot end design on these K1 printers feels so junk. It has a significant gap, so we're transferring the heat through a thick layer of low thermally conductive paste. But unfortunately, even a highly conductive paste didn't help, as I could not see any noticeable improvements. I additionally even swapped to the Arbiter with the extruder to see if the stock one was the problem. That requires you to install the Mainsail or Fluid interface for proper control and configuration. There are guides online how to do that, and it is quite simple, especially as the latest official firmware for K1 printers is no longer locked down. And the extruder upgrade definitely seemed to help, but realistically, come on, nobody wants to do this on their new 3D printer. So going back from the future to testing the stock printer configurations, next we have a print that will give the most representative look on how good your prints will look with Z-hubs that are required for the travel moves. And because we have such an inconsistent extrusion with K1 printers, it is impossible to say anything about the actual Z-axis movement consistency, as layers look automatically bad. I tried checking it with a dial indicator and it seemed perfectly fine, so most likely the main issue is with the extruder and the hot end. However, inconsistent extrusion is nothing compared to the importance of a good first layer. That is why I measure each printed square for the true first layer consistency. From all my printing experience with these printers and from the test results, the first layers of K1 and K1 Max were not impressive. What we want here is to have the least difference in the measured square thickness, but K1 series printers had more than twice the variance compared to the X1C. But is it fixable? Traveling to the future again, I played with a few settings that are tied to the bed mesh in Klipper. While the results were still not on par with the X1C, they were better. So again, let's go back to testing the stock versions of K1 series printers, and unfortunately they can't even get a break at input shaping test results. Although they run Klipper, which has an excellent input shaping implementation, prints here have ghosting artifacts even at low accelerations. But what I found out after all these tests is that their customized input shaper runs only on the y-axis, and the script always apply EI type of shaper results to the both x and y axis. On K1 and K1 Max, peaks of the x and y axis vibration frequencies are not that far apart, but the actual recommended input shaping frequencies differ by a lot. So the way Creality has implemented the input shaper makes no sense whatsoever. However, even when I calibrated the input shaper for each axis independently, I got only tiny improvements. My best guess would be that vibration frequencies are significantly different at the tip of a nozzle, or the motion system is too wobbly in general to predict vibrations accurately. Going back to testing the stock printers, I ran a print to see how well they printed the details. This requires tuning the pressure advanced value on each printer for the most apples to apples comparison. I don't know about you, but I couldn't see any real difference in this test. But where I could see the difference is with the X versus Y print results. Here we want the print to be the same length when printing on different axes. After all, these are enclosed core XY printers, so the accuracy of the practical prints is very important. To measure that consistently, I made a jig, and these are the results. Again, X1C performed better compared to the K1 series printers, but neither of them was even close to my build budget Warren 2.4, which is kinda crazy when you think about it. Another 3D print quality aspect that I feel is overlooked is the vertical fine artifacts that are created by the stepper motors at different speeds. K1 results here look quite poor, with a very narrow window of speed where the print looks good. K1 Max performs much better, but those results are miles away from the X1C with a newly released motor noise cancelling feature. And finally, the good old 3D bench print. Here I'm pushing printers to the maximum speed that is limited by the max advertised flow of a hot end. Surprisingly, all the prints looked quite good considering we're using the max advertised accelerations. Even a bigger K1 Max produced a decent looking print. Also checked how fast and how evenly heat beds are heating up. K1 required only 5 minutes to heat the bed to 100 degrees Celsius, and it had around a 10-degree difference in temperature on the build plate. Meanwhile, the heatbed of the K1 Max, which has a way more powerful AC heater, required around 9 minutes and had a 13-degree difference. And finally, the X1C took around 5 minutes to heat up evenly with only 5 degrees of difference. So what are my overall thoughts about these printers? First, the K1 Max. You know there's a saying, there's a no bad product, just a bad price? Well, at $900 it falls in a complete no man's land. Anyone spending that amount of money expects a polished product that prints great. Well, I can show you nice looking prints from the K1 Max that hide all the inconsistent layers due to their nature of being all curvy and stuff. The reality is that if you are buying an enclosed Core XY, you probably want to do some practical printing. While it prints fully usable ABS, ASA or TPU parts, those are nowhere as good as from X1C. They are plagued with inconsistent first layers, ghosting artifacts, some random extrusion problems, and bad looking layers. Not to mention that you can't easily make your bed as flat as possible like on the X1C with manual leveling knobs. K1 Max feels like a lazy upscale frame version as it doesn't even have thicker rods compared to the smaller K1, and the motion system feels extremely flimsy. Considering that P1S costs less and is basically the same printer as X1C, K1 Max feels just irrelevant. But what about the smaller K1? I feel like this is a way better deal, but it still needs a lower price as $500 feels too much for the performance that you get. Again, will your printed SpongeBob or any similar stuff will look bad? No, it will look great. The prints that will look bad will be those that require the most consistent precision in each layer. I think K1 with a lower price and with all the problems fixed can have the potential to be the budget Core XY option that runs Klipper and you can configure to your liking, plus you know that there'll always be some crazy mods for Creality printers. Overall, I feel like K1 series printers were rushed. Yes, they have some better design decisions than even X1C does, like lead screws are less in the way and you never bump your print plate into greasy lead screws, and the bottom is flat and not like a trap for all the trash from the prints like on X1C. But then there are design choices like fragile glass door, having a wrong type of hinges that almost always close from vibrations, or even worse, multiple gaps that let hot air and smell out of a chamber, the fact that you can't load filament unless you hold the PTFE tube straight, or the use of a graphite impregnated bushings with grease rather than long-lasting ball bearing ones. I really hope Creality won't abandon these printers and keep working on fixing the problems I talked about in the video, because there is some potential for them to be decent printers. So here you go, on your way out don't forget to drop a like and a sub for more true print quality comparisons of other printers. Huge thanks to all the YouTube and Patreon supporters, and well, that's all for me, and we'll see you next time.